class is on set. The definition of set is a well-defined collection of objects or ideas is called a set. The first question is, write the following set in roster form. B is equal to x such that x is a natural number less than 6. Natural numbers are 1, starting from 1, 2, 3, 4, 5, 6, so on. So the natural number less than 6 means we will write the numbers 1, 2, 3, 4 and 5. This will be less than 6 and this will be the roster form. Second question is x such that x is a 2-digit natural number such that the sum of its digit is 8. So we have, suppose if I take 26 as the number, this is a 2-digit number. 2 plus 6 is 8. Similarly, 35 if I take, 3 plus 5 is 8. If I take 17, this is a 2-digit number. When you add 1 plus 7, I will get 8. So our answer 17, 71. Write the reverse of 17. 17 reverse is 71. 35, 53, 26, 62. This will be the answer for 2-digit number such that the sum of its digit is 8. Next question is, G is equal to x such that x is a prime number which is a divisor of 60. So our answer will be 2, 3, 5. Divisor of 60 means when I divide 60 with 2, this is a prime number, 2 is a prime number, even prime number, 2 3s are 6, I am left with 0, this 0 I will write here, 2 into 30 is 60, so the remainder is 0. When you get the remainder divisor of 60, 2 is a divisor of 60. Similarly, 3 is a divisor of 60. Why? Because 3 20s is 60 minus 0. You are getting the remainder 0. So this means 3 is a divisor of 60. Same way, 5 is also a divisor of 60. So our answer will be 2, 3, 5. All these numbers are prime numbers. The next question is, write the following set in the set builder form. How we will write this? Suppose this as a is equals to, so I will write here a is equals to, the procedure or the method is to write in a set builder form x such that x is a multiple of 3, x is less than 5. I will write. Why I wrote this is, if you look at these numbers, 3 1s is 3, 3 2s is 6, 3 3s is 9, 3 4s is 12. So this is actually a multiple of 3. So I have written in the set builder form x such that x is a multiple of 3 where x is less than 5, because 3 4s is 12. So here the last number is 12. That's why I have written x is less than 5. The next question is, suppose this as b is equals to 2, 4, 8, 16, 32. How we will write this in set builder form? X such that x is in power of 2, comma, x is less than 6. Why I have written this is, If you look at these numbers, first number is 2. I can write it as 2 to the power of 1. It is equal to 2. The second number is 4. 4 I can write it as 2 square. The next number is 8. I can write this as 2 to the power of 3. Fourth number is 16 is equals to, I can write it as 2 to the power of 4. The last number is 32. I can write it as 2 to the power of 5. So x is in power of 2. Power of 2, this is x. So I have written x is in power of 2. So 1, 2, 3, 4 and so 2 to the power of 1 is 2, 4 is 2 square, 8 is 2 cube, 16 is 2 to the power of 4. That is why I have written as x is in power of 2, x is less than 6. Similarly, the third question is, suppose if I name it as c is equal to, so I will write the set builder form as x such that x is in power of 5. Why? Because and x is less than 5, or I can write it as, I can write this also, x is less than or equal to 4 also I can write here, this part. Okay, first number, look at the first number, it is 5. 5 to the power of 1 is equal to 5, and then second number is 25, that is 5 square. Third number is 125, that is 5 cube, and 625 is 5 to the power of 4. That's why I have written the answer as x such that x is in power of 5 and x is less than 5. The fourth question is, suppose if I name it as d is equal to, the set builder form will be d is equal to x such that x is a square of natural number. Square of natural number where x is less than or equal to 10. If you look at this number 1, I can write it as 1 square. So 1 is a natural number. When I square this, I am getting 1. For 4, 2 square. Second natural number is 2. When I square this, I am getting 4. Third natural number is 3. When I square this, I am getting 9. So I have got 1, 4 and 9. Similarly, 16, here 16 is missing. 16 I will write here. Okay. 4 square is equal to 16. So, and the last number is 10. When you square this, you will get 100. So, 1, 4, 9, 25 and 100 are nothing but x such that x is in square of natural number. These are the square of natural numbers. The next question is, state which of the following set are finite or infinite. The first question is, the first solution is finite. How we will solve this is, first I will take this question x minus 1 equal to 0 and x minus 2 equal to 0. Minus 1 when it goes to right side becomes plus 1, and minus 2 when it goes to right side becomes plus 2. So I have the answer as the roster form as 1 comma 2. Here I am able to count these numbers in the bracket 1 and 2. So the elements of these brackets are 1 comma 2. So 1 and 2 is the cardinal number of this, suppose if I name this as A, is 2. So 2 is a finite number. So that is why this set is a finite set. The next question is x such that x belongs to natural number and x square is equal to 4. We will solve this first. X square is equals to 4. Square, when you remove this square, here you have to apply plus or minus and under root 4. Under root 4 is nothing but plus or minus 2. So here also the solution of this set is plus 2 comma minus 2. This again is a finite set. The next question is x such that x belongs to natural number and x is odd. Here in this case the natural numbers which are odd. So the roster form for this will be 1 comma 3 comma 5 comma 7 comma 9 comma 11 comma so on. Why? Because here x is odd number is given. It is not given as x is odd number and x is less than or equal to 12. This part is not given. Here it is only given as x is odd. That means this odd numbers list will be in continuation. So that is why this we call it as infinite set. The next question is if a is equal to 1 2 3 4 5, b is equal to a b c d e, then find cardinal number of a. How we will read this n as cardinal number? So the cardinal number is nothing but the count of this set 1 2 3 4 5. Here I will write it as 5. And cardinal number of b here is, what is the count of b? Set of b 1 2 3 4 and 5. Here 5. So this is the answer.